Is the following solution acidic, basic, or neutral? So what I've given here is a salt, believe it or not. Now I'm going to show you how this salt was formed in the first place, and this isn't critical to answering the question, but it is a little background to help us understand. Okay, so this is a salt, and salts come from the reaction of an acid and a base. So what's the acid? The acid is HCN. Okay, so that's hydrocyanic acid, and the base is something that we call dimethylamine. It's what we call a nitrogen-based base. So here is dimethylamine. It's actually a base, similar to ammonia. And when we react these two, the base, the dimethylamine, grabs the hydrogen and becomes CH3 to NH2 with a positive charge. And then the cyanide is the conjugate base of our acid. So what we see here is the salt that I originally started with. So is this salt going to be acidic, basic, or neutral? Okay, so it depends on a couple of things. These two ions that were produced, the one from the dimethylamine and the one from the cyanide, they're both going to react with water and undergo a reaction we call hydrolysis. So now I'm actually going to answer the question. So the cyanide's going to react with water, a little bit of it, and the cyanide ion is going to take a hydrogen or a proton, a hydrogen ion or a proton from the water, and leaving hydroxide behind. So if that was the only thing that happened, we would say that this salt is a basic salt. However, in this case, the other ion also hydrolyzes. So the ion that comes from the dimethylamine has an extra proton or extra hydrogen ion. So it too undergoes some hydrolysis. It reacts with water, and it's going to form the dimethylamine, and that extra hydrogen is going to go with water to produce hydronium. Now, this reaction happens not a whole lot. It's in equilibrium, and this happens a small amount. So what we really want to know is how much hydroxide is going to be formed and how much hydronium is going to be formed. Which is going to be greater? If more hydroxide forms from the first reaction than the hydronium in the second, it's basic. But if more hydronium forms in the second reaction than the hydroxide in the first, then it's going to be acidic. So the way we're going to be able to tell this is we're going to use K values because this is at equilibrium. The greater the K value, the more likely the reaction's going to go more to the right. So we're going to actually look at the K value of HCN and of dimethylamine. So HCN is an acid, so we're going to look at the Ka for HCN, and it's pretty small, 4.9 times 10 to the minus 10th. And for the dimethylamine, it's 5.9 times 10 to the minus 4th. Now, we can't, and we would call that Kb. Now, the problem is that we didn't put HCN in water. We didn't put dimethylamine in water. We put the conjugate base, the cyanide in water, and it reacts to produce OH. So what we have to do is figure out the Kb for this reaction, and that's going to, because we're producing hydroxide, that's going to equal 10 to the minus 14 divided by my Ka, 4.9 times 10 to the minus 10th. Likewise, in the bottom reaction, our second reaction, we're going to have to find the Ka because we're producing hydronium, not hydroxide. So the way to do that is to take 10 to the minus 14 and divide that by the Kb, which is 5.9 times 10 to the minus 4th. So when we do solve for the Kb of our first reaction, we get 2.0 times 10 to the minus 5th. When we solve for Ka of our second reaction, we get 1.8 times 10 to the minus 11. So clearly we can see that our top reaction has a greater K value. So we would say that Kb is, for this reaction, is greater than Ka. So the solution is going to be basic. Furthermore, you can see that for hydrocyanic acid, the Ka is really, really small, giving us a stronger conjugate base. Remember, the weaker the acid, the stronger the conjugate base. Likewise, dimethylamine has a higher Kb. That means its conjugate acid is going to be much weaker at 10 to the minus 11. So once again, this solution is basic.